sometimes in organic chemistry, we want to know something about how much molecules stick to each other, because that stickiness between molecules determines some properties. Maybe the melting point or the boiling point, or what kinds of solvents they might be soluble in. Those sorts of things we can start to guess at or estimate if we know something about what causes molecules to stick together. The technical term for sticking these molecules together are called intermolecular forces, forces between molecules, or intermolecular. So let's take a look at some of the most important intermolecular forces. Let's jump right in. So for the intermolecular forces, there are three main types. One that's very strong, one that's more medium, and one that's weak. We'll start with the one that's medium in the middle. These are called dipole-dipole interactions. And a dipole simply means a molecule with a positive side and a negative side. It has two poles, positive and negative. And if you have a polar molecule, it has a positive side and a negative side, and you have several of these together, well, we see the positives and negatives begin to stick together, and there's a stickiness between them, sort of a bond between these molecules, and we call that an intermolecular force. And this particular intermolecular force would be a dipole-dipole interaction. So all of these positives and negatives would tend to stick together, and that would explain why a polar molecule may be something like a bent molecule with an oxygen on it, like this ether. It would have negative lone pairs of electrons on the top, very negative on its top, and very positive on the bottom. That's what this polarity arrow shows. Has a positive side and then points towards the negative side. This molecule has a negative side and a positive side. It has a dipole moment, so two of these molecules would begin to stick together with a dipole-dipole interaction. Now, all of these, the strongest to the weakest, you end up having some sort of dipole-dipole interaction, some positives and negatives sticking together. Now, the strongest case are a special case where we get very positive and very negative spots on a molecule. So you're going to get a very tiny positive spot and a very negative spot, and then that very negative spot will stick to the very negative spot to that tiny positive spot. And this special small positive and very negative spot, the very small piece, the positive piece, ends up being a hydrogen atom. So we call this hydrogen bonding because of that. That's the strongest kind of stickiness or intermolecular force. So an example of this would be when I have a hydrogen atom, which is very tiny, pretty weak, and it has two electrons bonded to one of the most electronegative, the strongest of the atoms. And we remember that those are things like fluorine, and those atoms very close to fluorine, like nitrogen. So libabicnafna. So fluorine has nitrogen and oxygen also very close to it. So if this hydrogen's on an oxygen, in the tug of war for these electrons, hydrogen loses and oxygen dominates. So oxygen pulls these negative electrons very close to the oxygen and makes the negative electron cloud even bigger on the oxygen. And it doesn't really matter what else is on that oxygen. It could be any kind of carbon group. But this hydrogen, because these electrons are pulled away from it, becomes very positive, like that tiny positive. And the oxygen, because these negative electrons get very close to it, because it's very electronegative, and it's got lone pairs of negative electrons on it, it becomes very, very negative. So that delta means partially positive, and this delta means partially negative, but this is very positive and very negative. Now, once you have this very positive hydrogen, it wants to stick to another molecule where it has very negative spots. So if you have one of these very electronegative elements, nitrogen, oxygen, or fluorine, and you have a juicy pair of negative electrons on that, it doesn't matter if there's a hydrogen there or not, but a very negative spot, very fluffy negative electron clouds, and all the electrons are being pulled close to it because it's an electronegative oxygen. So whether it's a nitrogen, oxygen, or fluorine, those are the three elements that we will have in hydrogen bonding. Then this positive hydrogen sticks to that lone pair on the negative oxygen, and that is a hydrogen bond. That is a stickiness between a hydrogen and a lone pair on an oxygen, nitrogen, or fluorine. And it only works if that hydrogen is on an oxygen, nitrogen, or fluorine. So you need two things. You need a hydrogen that becomes very positive. That only happens if it's on an oxygen, nitrogen, or fluorine. In that case, these become very positive, tiny and positive. That's one thing you need. And the second thing you need is you need an oxygen with a lone pair of electrons, or a nitrogen with a lone pair of electrons, or a fluorine with a lone pair of electrons. These electronegative elements are sucking all the electron density towards them, that negative electrons, and these become very negative spots. So if you have a hydrogen on an oxygen, nitrogen, or fluorine, and on the other molecules you have a lone pair of electrons on an oxygen, nitrogen, or fluorine, then those stick together in a very strong stickiness bonding sort of way in a hydrogen bonding intermolecular force. So the more you have this happening, the more those molecules stick together, the higher the boiling point will be for that liquid. I would have to make this very hot in order to make these molecules start to fly away. So that stickiness is called hydrogen bonding. And the weakest one, I'll just name it and we'll look at that in another video. These are called London forces, and I'll make a separate video talking about those weak ones. Now let me come back to hydrogen bonding and give you some examples. So let's pick a molecule like water. So here's my water. Now I have a hydrogen atom stuck on an oxygen, nitrogen, or fluorine. So this is a very positive hydrogen, partially positive. And on my molecule of oxygen or of water here, another molecule drawn, I have lone pairs of negative electrons on these very electronegative element like an oxygen. That's very negative. So these two stick together. This hydrogen, this positive, sticks to that negative oxygen. And if I have more water in there, this very positive hydrogen sticks to this very negative oxygen because it has a lone pair. And you can see that this can happen all over the place. Positive hydrogen sticking to a lone pair on an oxygen. Another water, so I can draw it all over the place. Another hydrogen sticking to an oxygen. So there's very negative spots and very positive spots. So you see it on things like this. You might see it on amines. Hydrogen on an oxygen, nitrogen, or fluorine. Yes, sir. That's a positive spot. And I have a lone pair on a nitrogen. Hydrogen bonding. Those would stick together fairly well. So the more hydrogen bonding you have, the more the boiling point tends to go up, the more you have to heat it up for these molecules to start to fly away. I hope that was helpful. Hey, like and subscribe to the channel so I can continue to help you in your organic chemistry journey.